let's look at the mean value theorem. If f of x is continuous on the interval from a to b, including the endpoints, and it's differentiable on the interval from a to b, not necessarily including the endpoints, then there's a number c in the interval from a to b such that f prime of c equals f of b minus f of a all over b minus a. So let's look at what this is telling us, because it's quite a mouthful. Let's say we have some function f of x. Let's say f of x looks like this. Okay, here's a and here's b. Notice what the right side of the equation is. That's the slope of the line that goes to the endpoints, because the numerator, f of b minus f of a, that's the change in y. So the top is change in y, whereas the denominator, b minus a, that's change in x as we go from a to b. So it's change in y over change in x. What the right side of the equation represents is the slope of the line that goes to the endpoints. The left side of the equation, f prime of c, is the slope of the tangent line at the point c. So what this theorem is telling us is that there's a place where the tangent line, there's a point c between a and b, where the tangent line has the same slope as the line through the endpoints. In other words, the tangent line is parallel to the endpoints, or the line through the endpoints. It's about right over there. Okay, that's about it. So that's what the mean value theorem is telling us. This is a foundational result in calculus, and the proofs of many important theorems are based on it, but we won't go into detail about those proofs. So let's verify that f of x equals x cubed plus 3x satisfies the hypothesis of the mean value theorem on 2 to 5. Then let's find all values of c satisfying the conclusion of the mean value theorem on the interval from 2 to 5. First, here are the conditions for the mean value theorem. F of x has to be continuous on the interval from a to b and differentiable on the interval a to b. So in this case, f of x equals x cubed plus 3x is continuous on the closed interval from 2 to 5 because it's a polynomial. Polynomials are continuous everywhere. They don't have jumps or breaks. And ditto, it's differentiable on 2 to 5 because polynomials are differentiable everywhere. You can take the derivative and it exists everywhere. Okay, so it satisfies the hypothesis of the mean value theorem. By the mean value theorem, since f of x is continuous on the interval from 2 to 5 and differentiable on the interval from 2 to 5, there is a number c such that f prime of c is f prime of f of 5 minus f of 2 all over 5 minus 2. In other words, there's a place between, again, we're looking at the interval from 2 to 5, there's a place somewhere between 2 and 5 where the tangent line has the same slope as the line through these endpoints. I don't have a ruler, so I'm just going to do my best to draw this. Yeah, that's okay. And I'd say, oh gosh, I don't know where that is. Maybe about over here. That'd be my guess. Okay. So that's where I'd say the tangent line has the same slope, where the tangent line is parallel to the line through the endpoints. Okay, let's check it out. By the mean value theorem, since it's continuous, okay, we already saw that, blah, 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 blah. So again, we want to find a point where f prime of c is equal to this. Let's calculate what this is. F of x is x cubed plus 3x, the derivative of 3x squared plus 3. So f prime of c is 3c squared plus 3. So there's got to be a place where f prime of c equals this quantity. And again, this quantity turns out to be 140 minus 14 over 5 minus 2, 126 over 3, which is 42. All I did was plug 5 and 2 into the equation to get 140 and 14. Okay, so the slope of the line that goes to the endpoints is 42, the answer to life, the universe, and everything. Okay, so there's got to be a point C where 3c squared, so the slope of this line is 42. It doesn't look like it has slope 42, but that's because the scale's unusual. Okay, so there's got to be a point C where the derivative is 42. Let's find that out. 3c squared plus 3, the derivative equals 42. 3c squared equals 39. C squared is 13. C is plus or minus 13. But again, we're only looking for points between 2 and 5. So negative 13 isn't going to cut it. So it looks like our answer would be c equals square root 13 equals 3.605, which is indeed between 2 and 5. Let's see how well I did this. Now, I didn't cheat by thinking, where is 3.605? Yeah, that's okay. It's actually a little bit further to the left, but yeah, that wasn't too bad.